homework number 9. And we're looking at problem number 8. We have another geometric series this time, and it goes 1/2 plus 2/3 plus 8/9 plus 32/27 plus ... on into infinity. And you're being asked to find the sum of the first 12 terms. Now they don't show all 12 terms, so, and I don't feel like figuring out what they are, but you can see what the pattern is here, can't you? What are we doing to get from one value to the next? Well, we're going to have to find a couple of things before we start. We're going to find our note card for the sum of a finite series. Do you have yours? Go ahead and grab that. And remember that in this formula we need the first term and we need the common ratio. So let's go ahead and find the common ratio between any two of these terms. You know what? I'm going to use these two, because remember what I need to do? I need to divide any term by the one before it. These two are going to be easy to work with, because my r is going to equal 8/9 divided by 2/3. This is an easy fraction division problem because I can actually divide the numerators and divide the denominators and get nice integers in both places. 8 divided by 2 is 4, and 9 divided by 3 is 3. So our common ratio is 4/3. Now we're ready to go back and plug everything in to our formula for the sum of a finite series. Again, we're supposed to be finding the sum of the first 12 terms. So we're going to be doing s of 12. Alright, s of 12 equals our first term, which is 1/2, times 1 subtract 4/3 to the 12th power, all over 1 minus 4/3. Toughest part about these is simplifying the expression before you calculate it, before you put it into your calculator. Let's see. We can certainly simplify the bottom. That's going to be 1/2 minus 1 1/3. 1 minus 1 1/3, excuse me. And I'm going to get negative 1/3. On top, let's see. I think it always works best if you distribute these. So I'm going to do 1/2 times 1, which is 1/2. Subtract 1/2 times 4/3 to the 12th power. I'm just going to write that down. 1 times 4/3 to the 12th power, because I'm not raising the 1/2 to the 12th power. But now the top I can put into my calculator, then hit equals, and then divide that by negative 1/3. So let's go ahead and do that. Alright, we have on top 1 fraction key 1/2. Subtract 1 fraction key 1/2 times 4 fraction key 1/3. Now the 4/3 is going to get raised to the 12th power. Now my calculator knows the order of operations, so hopefully it's going to give me the right answer, and it should. Now I'm going to be dividing this amount. Don't take it out of your calculator and write it down. Just leave it as is. Leave it in the calculator, and we're going to divide that by a negative 1/3, 1 fraction key 3. And I end up with a very large number, no, a small number, 45.854 if we round to the nearest thousands. Let's take a look after that 3. There's a 9, so I want to bump that 3 up to a 4. So here's our answer for the sum of the first 12 terms of this sequence. The fractions are getting bigger and bigger, closer to 1. That's why it ends up being a fairly large number.